Well, good afternoon, everybody. So, this will be just a short lesson, and today we are focusing on exponents. Exponents. Right, before we can even move on, I would like us to go through the laws of exponent. We have about 5 laws of exponent, and then we have definitions, and then we have sets. Right, the first law of exponent says when you have, okay, before we can even move on, I think it's important for us to define this. So in this case, in case I have a to the power of n, this a, we call it a base. This n, we call it an exponent. And all this a exponent n, we call it a power. Right, so the first law of exponent says when I am multiplying powers with the same base, so it's a to the power of m multiplied by a to the power of n, my answer will be a to the power of m plus n. So this law says when I'm multiplying powers with the same base, I will keep my base and I will add the exponents. That's why you can see that I have a, I kept my base. This is my base, it's the same. I kept my base and then I added the exponent. That's the first law. Then the second one says when now you are dividing powers with the same base, again you keep the base, but now you subtract the exponent. You can see that the base is the same. The base is the same. So you keep your base and you subtract the exponents. Right. Then we move on to law number 3. A to the power of m all raised to the power of n. So in this case, this is a power. Remember I said a power, I have a base and the exponent. So I am raising a power. This power I'm raising to another power. So this one will become a base, this one will become an exponent. This one is a base, this one is an exponent. Which means inside the brackets I have a power, and then even outside I also have a power. This will serve as a base. So when you are raising a power to a power, what do? You keep your base and then you multiply the exponents. Right. And then sequel number 4. Then now I have a product and I'm raising a product to the power of m. So which means this m will go to this one, it will go to this one. So my final answer will be a to the power of m, b to the power of m. Right. And then number 5, if I have now a quotient, so here it was a product, now it's a quotient raised to m. Again, this one will be distributed to each and every term, so it's gonna be a to the power of m over b to the power of m. Right, and then we have definitions. Definitions. So definitions. So the first one says a to the power of 0 is equal to 1. This one comes from the second laws of exponent. So I'm not gonna go deep to it and explain everything because of time. And then a to the power of n is the same as 1 over a to the power of n. Right, these are the definition. Okay, now I think it's very important for us to just do at least the example and see how do we apply these laws of exponents. Number one, for example, let's say we are given 27 to the power of 2 over 3. And then number 2, you are given 4 to the power of 3 over 2. Right, okay, negative 3 over 2. Right, so let's start from this one. So in this one, every time when you are dealing with the exponents, always try to change your base to be a prime number. Every time you rewrite all your bases into prime bases, and then you can apply the laws of exponents. So in this case, we have 27. We know that we can change 27 abobani 3 to the power of 3. We still have 2 over 3. Okay, now we are raising this thing. It becomes a power. So we are raising this power to another power. So this one is a base, this one is an exponent. This one, this bracket can serve as a base, and this one will serve as an exponent. So basically we are raising a power to a power, which is law number 3. So what do? I said to keep the base, you multiply the exponents. 2 over 3. So it's 3, this one and this one. So what is 3 to the power of 2? Your final answer is 9. Right. And then in this case, you change 4 prime base, 2 to the power of 2, all raised to the power of negative 3 over 2. Right, you are raising a power to a power. So what you do, you keep your base, multiply the exponents. 2 multiplied by negative 3 over 2. This 2 will take away this 2. You are left with 2 to the power of negative 3. So your final answer will be 2 to the power of according to the definition, if I have a negative, it's the same as 1 over 2 to the power of 3. 1 over 2 to the power of 3 is the same as 8. So here's the definition. So when I have a to the power of negative, I can write it as 1 over a to the power of positive n. So now I have the same thing, a to the power of negative n. I can write it as 1 over a to the power of n. So this will be the 2 examples that has to do with the third law of exponents. Right, then let us dive deep to more challenging problems. So this one will be example 2. Number 1, you are given 81x we have 81 x to the power of negative 3, y to the power of 4 all over 16x y to the power of negative 4 all to the power of negative 3 over 4. Right, again, if you look at this, your numerator, you have a product, in the denominator you have a product, and you have an exponent as well, which means there are so many laws that are involved here. So, but what we know is that we're going to take this one, multiply with this exponent here, take this one, raise it to this one, take this one, raise it to this one. Remember that when you have a, b, this is a product, and it's raised to the power of m, your answer will be a to the power of m, b to the power of m. So this m, the exponent m, it's going to be raised to each and every term inside the brackets. Even if you have a over b and they are raised to the power of m, this m is going to be raised to each and every term inside the bracket. So it's going to be a to the power of m over b to the power of m. Right. So let us now take this one and then raise it to this one, raise it to this one, raise it to this one. So it's gonna be 81. Okay, before we can even move on applying the laws of exponent, the first rule is to change our bases to be prime base. So how can we change 81 to be a prime base? 81 is equal to, you can use your calculator, it's 3 to the power of 4. So it's gonna be 3 to the power of 4, x to the power of negative 3, y to the power of 4 over, what about 16? 16 is the same as 2 to the power of 4. 16 is 2 to the power of 4. Then we have x, we have y to the power of negative 4, all raised to negative 3 over 4. Now, our bases are now prime bases. Now let us apply the laws of exponent, which means we are raising this one to this one, to this one, to this one, because it's a product. And also raise this one to this one, to this one, and to this one, because it is a fraction or a quotient. So what are we gonna do? We're gonna say 3 to the power of 4 multiply, because this is a power raised to a power. I keep my base, I multiply the exponents. Right. So it's gonna be 3 to the power of 4 multiplied by negative 3 over 4. Then I have x again. You do the same thing. It's a power raised to the power. Negative 3 multiplied by negative 3 over 4. Now y, you do the same thing. Y to the power of 4 multiplied by negative 3 over 4. All over. Again, you take this one, you're going to raise it to this one, and this one. So it's 2 to the power of 4 multiplied by negative 3 to the power of 4. Then we have x, 1 multiplied by negative 3 to the power of 4. And lastly, you have y to the power of negative 4 multiplied by negative 3 to the power of 4. Now let us multiply. So when you multiply, let me use a different color. This 4 will take away this one. Then you are left with 3. We are left with 3 to the power of, because a positive and a negative will give you a negative 3. Then I have x. This negative, take away the negative, gives you a positive. this one times this one, 9, 3 times 3 is 9. So it's 9 over 4. And then comes this one, 4 and 4. Then I'm left with y to the power of negative 3. Okay. Then this is a good denominator. This one takes away this one. And then I'm left with 2 to the power of negative 3. And then I have x to the power of negative 3 over 4. And then lastly it's y, this negative and this negative, 4 and 4. Then I'm left with y to the power of 3. Okay. And then here it's the same. I have a negative exponent, I have a negative exponent. According to the definitions, I can rewrite this as 1 over 3 cube. Then it's x to the power of 9 over 4, y to the power of negative 3. The reason why I'm not changing this y to the power of negative is because on the denominator I also have y to the power of 3. So I'm hoping they will divide each other. So over, even this one I can rewrite it as 2 to the power of 3. Then it's x to the power of negative 3 over 4, y to the power of 3. Right, so this one is 1 over 27 x 9 to the power of 4, y to the power of negative 3 over 1 over 8. Then I have x to the power of negative 3 over 4, y to the power of negative 3. Right. And then let us divide the numbers. This one is going to divide this one. So 1 over 27 divided by 1 over 8. It's going to be 8 over 27. And then this one and this one, powers of the same base, we are dividing. Let's keep the base. 9 over 4. 9 over 4 divide by, oh sorry, when we keep the base and we subtract, 9 over 4 minus negative 3 over 4. The answer is 3. And then lastly, I keep my base because I'm dividing powers with the same base. So it's gonna be what? No, my denominator here is not negative, it's positive. So what I will do, I'll say negative 3 minus 3. It's negative 3 minus 3. Negative 3 minus 3. Right. And then if I don't want to, I can say it's 8x to the power of 3 over 27 times 1 over, remember when I have the negative exponent, I can rewrite it as y to the power of 3. 1 over y to the power of 3. Then I multiply numerator with the numerator, denominator with a denominator. Right, so this one times this one, still I'll have 8x to the power of 3 over This one's gonna be 27y to the power of 3. Right, what's important here is to first change your base into prime bases, and then you apply the laws of exponent. Next. Okay, let us now do the last one. And it's not that challenging. Number 2, we have 3 to the power of n plus 2 multiply 9n plus 1 over 27 to the power of n minus 1. Right, first things first, change your prime bases. Change your base into prime bases. 3 is already a prime number. This one is not. We can change it. So it's going to be 3n plus 2 times 3 to the power of n. So 3 to the power of 2 all raised to the power of n plus 1 over 3 all raised to n minus 1. Right, it's gonna be 3 to the power of n plus 2. This one, multiply this one, and multiply this one. So it's gonna be 3. I'm raising a power to another power, so I keep my base, I multiply the exponents basically. So 2 times it's 2n. Then this one times it's plus 2 over this one times this one times this one. So it's gonna be 3 to the power of 3n minus 3. Right, power, same base. What I do, keep the base. What do I do with the exponent? I add the exponent. N plus 2 plus 2n plus 2 over 3 to the power of 3n minus 3. Right. This one plus this one is 3n. This one plus this one is 4. So it's gonna be 3 to the power of 3n plus 4 over 3n minus 3. Now I'm dividing again powers with the same base. I keep my base, subtract the exponent. It's gonna be 3n plus 4 minus, because we are minus, you need to protect, open the bracket, 3n minus 3. So it's gonna be 3 to the power of 3n plus 4 minus 3n plus 3. Then this one subtract this one. Then you have 3 to the power of 7. Or 3 to the power of 7 is the same as 2187. And this one becomes your final answer. Okay, so here's the tip. So whenever you have one term on the numerator and one term on the denominator, you change the base and then you apply the laws of exponents. But whenever you have terms that are more than one, maybe on your numerator, you need to find a common factor, and then you factor out a common factor, and then you try to simplify. Right, for example, let me just do this example number 3. So example number 3, I'll have 3 to the power of 2x plus 3 to the power of x over 3 to the power of x plus 1. So as you can see that I have 2 terms on the numerator, I have 2 terms on the denominator. So what I must do, I must try to take out the common factor, but first I need to break this first. So let me break it. It's gonna be what? 3 to the power of x all squared plus 3 to the power of x over 3 to the power of x plus, remember that whenever you have something that is equals to 1, it's 3 to the power of 0. That gives us 1. So we can rewrite this as 3 to the power of x all raised to 0. Okay, or we can say 3 to the power of 0. Right. Or we can just leave it like that. Let us just leave it like that and write 1 as it is. So what we're gonna do, we're gonna let 3 to the power of x above k, so that this thing is gonna be very simple. So now we have k squared plus k over k plus 1, right? Okay, so now on the numerator we have a common factor, which is k. Then you are left with k plus 1 over k plus 1, and then this one and this one will divide each other, and you are left with okay. And then okay, we know that it's equals to 3 to the power of x, and this one becomes your final answer. So here's the tip: whenever you have terms that are more than one, you look for a common factor, or you can try to change something that is the same. As you can see, now we have 3 to the power of x, 3 to the power of x. So you can try to make even this one 3 to the power of x, and then you can either use a k method where you change this thing okay, or you can just take out the common factor. If let's say on this one I decided to say 3 to the power of x all squared plus 3 to the power of x over 3 to the power of x plus 1, and then I say take out the common factor, which is 3x into 3x plus 1. It's the same as 3x plus 1, so this is the same as this one, and I'm left with 3 to the power of x. Then this becomes my final answer. I'll still have done that, but when you are using a k method to make it easy for yourself to see, I have a common factor among these two, so I factor out, because I can't factorize this one. Even if you change this one to 3 to the power of 0, it won't help you. So you factor out the common factor, and you have something that's the same as the denominator. Every time you will have something that is the same as what you have on the denominator, and then you can divide the two, and then you simplify your expression. But if you have one term on the numerator and one term on the denominator, change your bases to prime base, and after LAPO you apply the laws of exponent. Okay, have a lovely and a wonderful evening. Enjoy the rest of your day. Thank you very much.